Welcome to this talk on Silex anatomy. For those of you who don't know me, my name's Igor. I'm one of the co-creators of Silex. And the main question that I would like to answer today is, would you rather fight one elephant-sized duck or 100 duck-sized elephants? So first of all, I'd like to share my thoughts. Is this all right? I'd like to share my thoughts on what Silex is from kind of a more inside perspective. So Silex is a test suite for Symfony, and it's a test suite in two distinct ways. So for one, it is an actual test suite because Silex does have tests, and it's testing the Symfony components in a specific configuration, kind of acting as an integration test. It's also a moral test suite. And what I mean by that is that, well, Symfony is kind of two things, right? So you have the Symfony framework and the Symfony components. And the Symfony framework is composed out of these components. And the components have made certain promises which need to be enforced. So for one, there's the backwards compatibility contract, which means that in a new version of the Symfony components, you can't just break everything. So you need to retain a certain level of backwards compatibility. And well, since the Symfony framework is the main client of those components, it could be, or it could happen that certain changes are made specifically for the framework, which break other users. So by having an alternate framework that uses the same components, there is some way to ensure that if something breaks, we will actually notice it, and we can kind of slap back to Symfony and tell them to stop doing that and stop breaking other things. And as soon as more people start using these components, which is happening, like we have the Laravel 4 framework, and Drupal is using it, PHPBenelux is using certain components. So it is rapidly expanding, and it will become more and more important to retain these compatibilities. Silex is also a Trojan horse for dependency injection. So dependency injection, it's really quite a simple concept, and it's not been that well known in the PHP community. So it only really became popular during the last few years, I would say. And well, it's kind of scary because you have all of these new concepts, you have containers, and what Silex does really well is hide this hide the concept of a DI container away from you while still giving you the possibility to use it if you want to and to customize bits. So by hiding the fact that there is a container there but still providing you the opportunity to override services, like that, you can appeal to people who don't necessarily want to learn all of that stuff, and they can still use it without knowing about it. But as soon as they do hit certain limits and want to customize things, then they can start using it just fine. And Silex is also bloated. So if we take a look at the application class, which is the main class that you interact with when you use Silex, and if I scroll down right to the bottom here, it's about 500 lines of code in one single class, which is pretty massive if you ask me. And if we take a look at the class definition, then you can see that there's an application class which extends Pimple. So Pimple is the dependency injection container used by Silex, which is the worst name ever. And it implements, sorry?
Especially when you Google for it.
Yeah, when you Google, don't Google for it. And so it extends Pimple, it implements the HTTP kernel interface. So obviously there's quite a few responsibilities that are mixed up inside of this class. And I would say there's a few main responsibilities. So for one, it's the root builder. And this is, to me, this is the main responsibility of Silex. So when you call methods like get, put, post, delete, what you're doing is you're building roots, or you're defining or declaring roots. So that would be the main responsibility. Then you have Pimple, so it's also a container, and you have the HTTP kernel interface. And in addition to that, you also have the run method. So you have a kernel and a front controller, also in the same class. And in addition to that, certain utility functions as well. So there's all kinds of stuff here. And, well, showing the Silex code base to explain the concepts, it doesn't work so well because it's kind of hard to see the different responsibilities and what belongs where and which part does what. So we're just going to close that now. And let's talk about monolithic frameworks and libraries for a second. So I guess most of you have used monolithic frameworks before, where everything is kind of packed up into one huge package that contains everything, that has an ORM, that has a routing library, that has a templating engine, and everything inside of it. And it really sucks because you can't customize things. You can't make your own decisions. And you're forced, well, at least in most cases, you're forced to use the things that are provided by this framework. So I'm not really a fan of frameworks. I really prefer libraries. And to me, Silex is more of a library than a framework, because you are mostly in control of how you use it, and it doesn't really make too many decisions for you. And the decisions that it does make, you're able to override them if you want to. So I think the main difference between monolithic frameworks and something like Symfony is that Symfony is decoupled. Symfony has components. And this also applies to Zen Framework, more now than it was with Zen Framework 1, but the idea is the same. So what do I mean by decoupled? Well, these decoupled components, for one, they're independent. So I can use one component without dragging in all of the framework, or without dragging in 20 different other components. So I can just use them standalone, and they aim to be as standalone as possible. And what's really awesome about this is that you have interfaces between the components, and that's how you communicate between them. So by having these interfaces, you're not bound to a specific implementation, but you can replace it with something else if you want to, which is the third point. So it makes things and pieces and parts replaceable. So to me, this is a little bit like Unix philosophy. These components implement Unix philosophy. They try to solve one specific problem and solve that problem well, and they provide an interface through which you can communicate with it, and through which you can compose it with other things. So this brings us to Yolo. And Yolo is this concept that came up within the last few years, which is essentially it's a disease which destroys any form of culture. And what it boils down to is teenagers doing stupid shit because our time on this planet is limited. And I claim that the PHP community has had this concept for a long time. We just didn't quite have the right word for it. So in the PHP community, we call this thing frameworks, because everyone has their own framework. Everyone has invented their own framework. There's so many new frameworks coming out every single day, and most of them don't really bring anything new to the table. They don't really add any value to the community. And so what I wanted to do was to take the idea of Silex and make a more academic version with all of those dependencies that are mashed up in the application class and kind of tear them out and tear them into separate classes. So since I'm creating a new framework, I might as well call it Yolo. Yeah, I'm never going to be able to complain about naming again, I think. So let's take a look at the Yolo code base. So here it is, and the first thing that you should look at when you look at any code base is the composer.json file, obviously. Can you see that all right? Okay, so you can see it's a microframework with swag, and it has a set of dependencies. And most of the dependencies are, in fact, the same ones that Silex has. So we have the HTTP kernel. And the HTTP kernel, I think, has a really good name because it really is kind of like an operating system kernel. So you can think of it as the Unix of the web, if you will. And the HTTP kernel has two dependencies. One of them is the HTTP foundation. And the HTTP foundation, okay, so the kernel essentially holds everything together and lives at the heart of the web application. And it's like the engine. It's like a kernel. And then the HTTP foundation models the HTTP request and response in PHP objects. And so the foundation is kind of like standard in and standard out. And then we have the event dispatcher, which is the other dependency of the kernel. So the kernel depends on foundation and dispatcher. And the dispatcher is kind of like an event signaling system. So in terms of Unix, you could think of it like operating system signals or ports that you can connect to. So those three are kind of the main ones that make up the core of the system. And then there's routing, which, just to push the metaphor a little bit, is maybe a bit like a scheduler. So this decides which requests go where. So it kind of, I'm really sorry about this, which decides how to route things around. And so then the replacement for Pimple, because I didn't want to use Pimple in this example, is the dependency injection container or component, which is using two additional dependencies. So it's using the config and the YAML components. And you could easily replace those with Pimple. The reason I didn't do that is because I wanted to show you YAML files to look at because they're pretty. OK. So let's take a look at the hello world of Yolo. And so as you can see, this is a bit more verbose than Silex. And that's kind of the point. So Silex is really optimized towards the end user. And Yolo is optimized towards seeing the pieces and understanding them, which means that it's obviously going to be a bit more verbose. So there's a factory call for the container. And the container it's essentially like the bootloader of the system. So it bootstraps everything, it loads it up, and allows you to get started. So if you think of these different components as a part of the OS, then the framework itself is kind of like the user interface, because that's what you, as a developer, as a user of this framework, that's what you interact with. OK, so once we have the container, we can fetch services from this container. And in this case, we get the root builder. So this is, instead of having all of those methods on one kind of God object, they're really more separated out nicely. And if we take a look at this root builder, this is all it takes. So it takes a root collection as an argument to the constructor. And whenever you call one of these methods, get, put, post, delete, it just adds a root onto the root collection. And that's it. There's really nothing more to it. And this is, what, 40 lines of code. That's nothing. So then this is how you use it. So this is pretty much the same as in Silex. One major difference here, though, is that there is a mandatory name that you need to give it. And the reason for that is that one of the parts of Silex that causes the most annoying code is the fact that you can set the name after defining the root. And because of that, so if we go back into the root builder, if you look at the root collection, when you call add, you need to specify a name. So as soon as you add something to the root collection, you need to have a name for it at that point. And what that means is that if you want this name to be mutable, you have to have some kind of staging area where you stage all of the roots. And as soon as you know definitely that this name is going to be OK and you don't want to change it anymore, then you can kind of freeze it and at that point put it into the root collection. So that's what Silex has to do. And it's quite a chunk of code just to do that. So then in the end, you get the front controller and you call the run method. And the front controller, this is pretty much just copy-pasted from Silex's run method. It's doing exactly the same thing. So yeah, that's pretty easy. So what about the container? So if we take a look at this factory thing, this just creates a new container builder, registers a container extension, and all of this stuff. Who has worked with Symfony? OK, quite a few. So this concept of a container extension, you probably know that already if you've worked with Symfony. So it's registering this container extension, which is like a Silex service provider. And then it sets some parameters, and it adds an event subscriber pass. So the construction of the container has this phase where you define services. And then it has a compilation process where it runs through a set of compiler passes, which allows you to modify the in-memory, well, it allows you to modify the representation of the container in memory, which we'll see why that's useful in a sec. And the extension itself, this is exactly the same as you would have in a Symfony app. So it just loads from a services.yaml file. So yeah, these classes are really small and don't really do that much. So if we take a look, So if we take a look at the services.yaml file, the interesting thing to notice here is that this file is actually pretty much the largest file in the whole project. And so that's kind of interesting. And what this does is just define how to wire the pieces together. So it's pretty easy to do this. And so we have these different pieces. And actually, I'd like to take a look at, just a sec. There we go. I have one single slide for this presentation. And this is it. So the way the HTTP kernel works is, this is essentially the abstraction where the request comes in and the response goes out. And it takes the request, so it comes in here, takes the request, and then it goes through the event dispatcher and just starts notifying certain events. And then there's listeners that can listen to these events. And then it uses the controller resolver to determine, based on the routes, which control, essentially converting a route to an actual executable controller function. and then it just goes back to the kernel and returns the response from the actual controller that it found. So the HTTP kernel is the default implementation of the kernel interface, and it's really cool because it's this small piece that you can just take and use. And you can just hook into it using listeners. You don't have to extend it or anything like that. You can just add listeners to it and start using it. OK. So if we take a look at the service definitions and how these things are wired together, you can see we have an HTTP kernel, which takes a dispatcher and a controller resolver. And the dispatcher doesn't have any direct dependencies. So how do you get listeners registered with the dispatcher? Well, that's where container tags come in. So if we go down here, we have these listeners. And actually, if you want to find out from the Symfony code base which listeners are available, you can just look at the event dispatcher class. And it has this method called, so it has add listener, which takes a listener function. And it has add subscriber, which takes this event subscriber interface, which is essentially an object that encapsulates a number of different listener functions, which allows you to, in a more formal way, subscribe to a set of events. So to see which default listeners or subscribers are available, you can just check which classes implement this interface. So you can just search implements. There we go. And so let's see. So we have a few interesting ones here and a few not so interesting ones. The main ones are the exception listener. So that one allows you to render, to catch an exception and render a nice error page for it. Then there's things like locale listener, which allows you to do encoding stuff. There's the response listener, which allows you to prepare the response, which is, so the thing is, you have certain redundancy in HTTP response headers, like the HTTP caching headers. There's some kind of redundancy between those, where you have the old way of doing things with the expires header, and then you have the cache control headers. And the response listener allows you to prepare this response so that that stuff is normalized. And then there's the router listener. And the router listener is probably the most important one. So if we take a look at the definition of the router listener, it takes the service definition. It takes a URL matcher. And the URL matcher is just an instance of this matcher, which has access to the roots, which are the root collection. So that listener will automatically look up, given the current request, look up in the root collection which one of those roots matches, and will then return the controller for those roots. So yes. And this is really flexible. Having these service definitions is a really flexible way of is really flexible because it allows you to add functionality without changing the code. So one example that I'd like to look at, and I hope I have internet, is how to add logging without changing a single line of code. So if we look at the HTTP kernel, then we have, oh no, if we look at the router listener, then we have the matcher and the context, which you've already seen. And then there's an optional argument of a logger. So you can pass a logger into this listener, and it will just log things on there. And this is using the logger interface, which is PSR. So who's familiar with PSR? Okay, so PSR is a set of standards or recommendations for interoperability between libraries and frameworks. And there was one of these was recently passed named PSR3, which is a standard logging interface. So this allows you, essentially any library can consume any kind of logger, and as long as it implements this interface, you don't really have to invent your own custom concepts or your own interfaces for logging. You can just use this one, and then if you do that, you can use any logger that implements that interface. So it's a means of decoupling the consumer, which is your library that wants to do logging, from the actual logging implementation. So one of the, I don't know, probably the only implementation that implements that is Monolog, which is a logging library. So in order to add that, just go to composer.json, add the monolog/monolog dependency, and I believe it's version 1.3. And then I'm just going to increase the font size. So then if my internet is working, I should be able to do composer update. And let's just hope this works. This doesn't look good. Yes? No? Okay. So I guess I already had it checked out from a different branch. But yeah, so we have Monolog installed, which means that we can now add this Monolog instance into the router listener as an argument. So first, what needs to happen is that needs to be defined as a service. I'm just going to close this stuff here. So we have the services.yaml and the router listener and the Monolog logger. And the Monolog logger implements the PSR logger interface. So this is an implementation that you can use with the router listener. And the logger class takes a name as an argument. So if we go to services.yaml and define this service, it's a logger of class Monolog logger. And it takes arguments, a name. I'm just going to call it app because I'm lazy. And what you also need to do is define on the logger a set of handlers, because you want to be able to actually log somewhere. So the logger has a list of handlers, and whenever you log something, it will just notify those handlers, and they will do whatever they want. And there's a set of standard handlers that you can use. So we're going to use the stream handler. I think that's the name. Monolog stream handler, yes, which operates on any PHP stream. So Monolog handler stream handler. And let's just check the arguments. So it takes a stream, which can either be a URL or the actual stream resource. And what I'm going to do now is just mistype arguments. Is put PHP, I think it's PHP output, or is it standard out? We'll see. So I'm going to use the PHP 5.4 built-in web server. And this allows you to log to the actual terminal window that is running in. So if I just do make web, which is just going to run this example in this on this port in this window. So now, if I open this up, okay, so now we have a stream handler and we have a logger, but the stream handler is not defined, is not being added to the logger yet, so we need to do that as well. So we add a call to push handler. So this just adds a method call for the push handler method on the logger, and we can define what we want to push. So we're going to push the stream handler. And I got this totally wrong last time, so I hope this works. Okay, so the next thing we need to do is add the logger as a argument to the router listener. So just add that there. And it logged to this window, which is not what I wanted. So let's try the other one. I think it's not output, but standard out. See if that works. So yeah, there you go. So now we have a basic form of logging, and I didn't even have to change a single line of code. So this is all done purely through configuration, which is quite nice. So having standard interfaces really goes a long way, because it allows you to use any implementation of, in this case, a logger, but it could be something else like a router. So if I wanted to use the Zen framework router, I could just use that one instead, as long as I have a way to adapting the interface to the interface that the rest of my code is expecting. So that really goes a long way and allows you to compose things really nicely. Okay, so one thing that you saw is in the example, in the Hello World example, there's this error page which just throws an exception. And this is actually using the error listener, the exception listener, which renders the exception in a nice way. So if we go to /error, then you can see this is the same as the Silex error page. And by default, it shows you the stack trace and everything. But in production, you don't really want that, right? So making this configurable is actually really easy. So what I want to do now is add a debug parameter. And so if we go, if we take a look at the exception listener, there's an argument which is exception controller handle. And the exception controller service is a class inside of the Yolo code base, which takes a debug exception handler, which is part of the HTTP kernel component, and it just uses that to render the response. So the listener expects a function that is able to render a exception based on the exception parameter inside of the request, and the exception controller is a implementation of that, and the debug exception handler only cares about the exception itself, so that's why you kind of need to wire together these three objects, because the exception handler doesn't do this part automatically, right? Okay, so this creates a response for the exception, and if we take a look at the debug exception handler, it has this debug argument which defaults to true. So essentially, and this is the same thing as the Silex debug argument or debug parameter. The debug parameter should be able to configure this and disable the stack trace in production. So if we go back into the configuration, the exception handler currently takes no arguments. So what we can do is just say arguments, and the argument is just the debug parameter. And this is, well, it's just a magic syntax for referencing parameters. So we have this debug parameter now, and maybe we want to define a default value for that, because if you don't define it, you'll get errors. So if I try to run this now, it will explode and say, what is debug parameter? I don't know what you're talking about. So if we just do parameters debug, and it defaults to true, because just to be different. So now it works again. And so what we can do now is go back into the hello world example, and if you were paying a lot of attention, then you notice that there's the parameters argument for create container. So we can just pass this parameter here. So let's do that. So we have debug. I can't type. False. And now it's gone. So this is, again, there was no code changes involved. It's really just configuration in the end. So this is quite nice. Let's see. Okay, so the fact that these components are kind of isolated and trying to solve one problem well is the good thing about that is that they kind of have some more advanced parts to them specific to that component. And one example for that is the container. So the thing is, I/O is really slow. So loading files from disk is really expensive. And one place where you will notice this with this code base is going to be the services.yaml file. Because if you load that file from disk on every single request, that's going to be slow. And in addition to that, since it's using this fancy YAML format, it also means that we need to parse that format, which is even slower. So, well, depending on your disks, whatever. But so both of those things are extremely slow. So there should be some way to deal with this. And the way you can deal with that is once you've loaded from YAML into memory, you have this possibility to dump the in-memory container back into other formats. So you could dump it back to YAML. You could dump it to XML if you like Java. Or you could dump it to a PHP class. And I have an example of that here. So this is all of the code it takes to dump the container into a PHP class. And if I run that, dump container, then you can see it just generates the code. And for each service definition, there is a method which will construct all of the dependencies. So you have, what the hell? So you have the front controller, which depends on the HTTP kernel, and it will, well, it will recursively construct it. So what you do if you want to use this optimized version is you need to have some kind of caching. Usually you would have some kind of cache directory. And then as soon as you have the container built from the YAML file, you just dump that into the PHP file. And on subsequent requests, instead of loading from YAML, you just include that file. And creating the container is as simple as just creating a new instance of that class. So this allows you to get certain optimizations, which is kind of a big deal in this case. And what's also kind of nice is that you have a separation between compile time and runtime. So if you have any other expensive operations, as long as you do those during compile time, it's probably still not a good idea to do that, but at least you can get away with it. So you can do really expensive things for the container construction, and then once you've dumped the result of that into a PHP file, you don't care how long it takes because the compiled version has all of the results in it. It's going to be fast anyways. So another example of why these components are pretty cool and the fact that they are libraries is pretty cool is that you can query the object graph. You can get information out of there. And one example of that is dumping all of the roots. So if you want to know which roots, let's say you have a largish application with lots of roots in it, and you want to have a quick overview of which roots exist and what their names are, then you can do something like this. So this top part here is the same as the example, because I have the front controller in the same file, so I couldn't really share that piece of code between those two files. But anyway, so this is all the code it takes to dump out the roots from the root collection. So you can just get the root collection, iterate over those roots, and echo out the names and whatever properties from the actual root that you want to. So if I just run that one, you can see it's, well, it can be quite useful, and it's extremely easy to do this. So yeah, kind of nice. So I guess one of the things that I'm trying to say is that when you have a service configuration like this, since this is the largest file in the project, the configuration is essentially in the graph. So the logic is not completely, but to some extent, the logic is in the graph, in the combination of the pieces. And the pieces themselves are more or less standalone, more or less, well-defined in what they do, and more or less generic. So they're not doing something specific, but they're actually reusable pieces that you can adapt for different use cases. And this is kind of, in a way, this is a bit related to flow-based programming, where you have a system of things that are connected and of ports and adapters where they just connect together. And it's also slightly related to functional programming in the sense that you have this thing, the HTTP kernel, which really takes a data structure, the request, and returns a data structure, the response. So this is, yeah, it's not really a pure function in the true sense of the word, but it kind of goes in that direction. It is more or less a function. So to make some final points, I think Silex is bloated, but it doesn't matter because Silex is optimized towards the end user. And if you look at this, I wouldn't want to use this. It's just too verbose. It's too much code. And with Silex, it's really nice because you can just create this thing and use it right away without having to care about the internals, without having to care about the container, without having to care what a front controller is and what a service is. So this is nice to look at, but I wouldn't want to use it. So hopefully I was able to give you some ideas about, or some new ideas about how to think about frameworks, because a framework, it's really just a tool made of libraries. It's not a religion. It's not supposed to be this one true way, but instead it should be a tool for you for solving problems. So a clear separation and interfaces really goes a long way. By having that, you can compose things in different ways, you can adapt things, you can replace them. And composing small parts together is really awesome, because it allows code to be used in many different and sometimes unexpected ways. So finally, I don't know about you guys, but I would much rather fight 100 duck-sized elephants like this one, because they're kind of cute. So with that, thank you.